All right, cool. This is going to be short and sweet, but this is going to be working backwards. And what if you want to write your own equation from a polynomial graph? So a couple things to think through, or actually the easiest thing is to decide what form you want to write your equation in. Now, if you're asked for factored form, it's going to be a happy day. If you're asked for standard form, we're going to have to do a little bit more work. But let's assume you were asked for the factored form of the equation. First thing that I would check is going to be the x-intercepts. You know, it looks like we're crossing the axis at -3. And so if you're crossing the x-axis at -3, it means that x plus 3 is a factor. And if you're crossing through nice and pretty, it's just a solution, or it has a multiplicity of 1. If you're not sure what multiplicity is in graph behavior, you'll need to watch my other video called Factored Form of Polynomials. Okay. The next solution is right here, it looks like, at -1. So x plus 1 will be the factor. Now here, the graph doesn't go through, it bounces, so that tells me it has a multiplicity of 2. And then the other thing I notice is that it crosses at +2 on the x-axis. However, it's not a normal cross. It flattens out a little bit as it crosses, which that means it probably has a multiplicity of 3. Now, I wish I could say that we were done, but you do want to take your y-intercept into account as well. So in this problem, the y-intercept is shown as a 2. Okay, so the point 0.02 looks like it's on the graph. So the way I handle this is I basically think, well, there might be a dilation on this problem that we can't see. You know, something that's stretching it or shrinking it that made that y-intercept go to 0.2. So the easiest way to check it is to set up sort of an equation, right? Because if you are a y-intercept, your x value is 0. So what I'm going to do is I'm going to take this point and I'm going to plug it into this equation. I'm going to plug in the 0 for x. I'm going to plug in the 2 for the y. And the a is just an a. Like, I don't know what it is. And that's kind of the goal, is to figure out what that is. Because if you figure out a, you've just figured out your dilation. So now I'm just going to do some math. So 2 equals a times, let's see, 3 times 1 times 2 to the third, actually negative 2 to the third, right? So that would be a -8 times a 3. I'm getting a -24 here. And then if you want to solve for a, you could just divide both sides by -24. And that would just be a -1/12, wouldn't it, when you make that division? So the final answer in factored form would be -1/12, and then all that junk I wrote before. I also like to think through end behavior to make sure everything makes sense. Let's see, this is x and an x squared and an x to the third. So this is really like having an x to the 6th as sort of my highest degree if I add up all these different x's. And in the front I have a -1/12. So it's negative and it's even. So it should be going down on both sides, which lo and behold it is. So this is just kind of me checking my equation to make sure things make sense in the end. But that's pretty much it. Now, if somebody wanted standard form, that would actually be not very nice. Because if somebody asked you for that, guess what you're going to get to do? You're going to get to multiply all of this out. Like, all of this. I'm not going to do it because I don't want this video to be 20 minutes long. Because it would take me probably 10 minutes. Oops, I meant to write this different. But like, you're going to have to do, oh gosh, see what I'm saying? See what I'm going after here? It's like such a headache. You would like foil these, then distribute it into that, then distribute all that into that, then distribute all that into that. It would take you a long time. So hopefully no one asked for standard form on something this funky, but factored form, perfectly acceptable, not too terrible. Thanks.